Okay, let's look at example 6 here. It says find the indefinite integral, which is the integral of 2x over x plus 1 quantity squared with respect to x. Again, here we do have kind of the same power here, but not really, because we do square this out. And so if you square this out, let me show you what this would look like. This would be the integral of 2x over, well, if I FOILed that out, it'd be x squared plus 2x plus 1. And this is with respect to x, right? This one gives us a serious issue, because if we let u equal x squared plus 2x plus 1, this would not work, because we'd have du would be 2x plus 1, and it wouldn't simplify properly. So this is absolutely not the strategy that you want to do in this problem. However, let's try u substitution with what they call the change of variables. And you'll see what I'm talking about. We did some problems like this in a previous section. So what are we going to do? Let's let u equal the inside of the parentheses. So in this case, it's x plus 1, right? So let's keep on going. So step 2 would be find the derivative of both sides. So du dx would be equal to, well, the derivative of x squared plus, x plus 1 is simply just a 1. Step 3 is solve for dx, right? So here we'd have dx equals du over 1, which is simply du. And again, we're going to substitute in for dx, which is du, and we're going to substitute in for u. When we do that, what would I have? So if I rewrite my integral, this is step 4, I would have the integral of 2x over u squared, and then this would be du. And that's a problem, right? Why is that a problem? Why is this a problem? It's a problem because we still have some x's in here. So what are we going to do? Well, what we need to do is we need to look at, if u equals x plus 1, could I solve for x? Well, simply subtract 1 from both sides, and I get x equals u minus 1. So when I look at this, I could substitute back in for x in this original one right here, and I would have this would equal the integral of 2 times u minus 1 all over u squared, and this is du. So let's keep on working on this. This would be the integral of 2u over u squared minus 1 over u squared. If I separated this, minus 2 over u squared. This is what I did, was I distributed the 2, and then I separated it. So I just did 2 times u, and then I did 2 times 1, and then I separated it into 2 separate problems. Now my u's are going to simplify here, and let's see what we get. I'm getting the integral of, how about 2 times the integral of 1 over u du minus 2 times the integral of u to the negative 2 du. And that is in the form that I can actually integrate it. So I'm going to move on to step 5 now and actually integrate it. So what's the integral of 2 times 1 over u? Well, that would be equal to 2 times the natural log of the absolute value of u. Then we have minus 2 times the integral of u to the negative 2. Well, using the power rule, that would be u to the negative 1 over negative 1. Of course, we have our plus c. Let me clean that up a little bit. This is 2 times the natural log of the absolute value of u. The negatives cancel, so I'm going to end up with plus 2 over u plus c. And then again, remember the last step that I have to do is back substitute for u. So go back to the original part, the first step of this entire thing, and I'm getting step 6, back substituting for u. I would have 2 times the natural log of the absolute value of x plus 1 plus 2 over x plus 1 plus c. And there's my final answer. 2 times the natural log of the absolute value of x plus 1 plus 2 over x plus 1 plus c. So again, if you started out by trying to distribute or FOIL out that denominator, it would not work. Your u substitutions would not simplify properly, and you would have issues left over. So what we did is we substituted in for u and dx, and then we had to solve for x in terms of u. I know you did that on a few of the problems in the previous section, so hopefully you can catch that and do that here. So let's look at what they say here is guidelines for integration. It says learn the basic list of integration formulas. In other words, learn everything backwards. It says find an integration formula that resembles all part of the integrand by trial and error. Find a choice of u that will make the integrand conform to the formula. So try u substitution. It says when you cannot find a u substitution that works, try alternating the integrand. So this is where you try trigonometric identities. You might try multiplication and division by the same quantity, addition and subtraction by the same quantity, long division. This is where you get all those algebraic tricks that we've learned before. And then it says if you have access to a computer software that will find antiderivatives symbolically, use it. That's cheating, okay? So don't do that. And then number 5, it says check your result by differentiating to obtain the original integrand. Okay, so always check your answers is all that's saying right there. So this right here is cheating. So only use to check answers. Okay. I'll let you know in this class it's considered cheating. In the real world it's called the norm. So in the real world you are going to use computer algebraic systems such as Wolfram Alpha to integrate these integrals for you, but in this class the whole sole purpose is that you can do them by hand. Alright, let's move on to number 7. Number 7 says solve the differential equation dy dx equals 1 over x ln of x. Again, what are we looking for here? Dy dx equals 1 over x ln of x. That means we want to solve for y. So how do you solve for y? We need to integrate it. So what they're looking for, is this is a differential equation, is they're looking for the integral of 1 over x natural log of x with respect to x. This one's a really cool problem, a really typical test problem for the majority of math teachers because it's a nice trick that if you didn't see it, you wouldn't know how to do it. So let me show you the trick. What's the trick on this one? The trick on this one is to let u equal the natural log of x. Not something you probably would have thought of, but that's what it is. Let's see why that is the trick. Move on to step 2, differentiate both sides. You'd have du dx would be equal to, well, the derivative of natural log of x is 1 over x. Again, we're going to solve for dx. Let's be careful here. In solving for dx, I have to multiply both sides by dx, and then I actually have to multiply both sides by x as well. So dx would actually be x du when I do my cross multiplication. Okay? So what do I do here? Always substitute in for dx, and always substitute in for u. Rewrite your integral here. When we rewrite our integral, which is step 4, we're going to have the integral of 1 over x times u, and then instead of dx, again, that was x du. Notice what happens. Those x's simplify now, and I'm left with the integral of 1 over u du. That's awesome because that gives me exactly what I need to be able to integrate. The integral of 1 over u is the natural log of the absolute value of u plus c, which is easy enough. No simplification, sorry, needed the highlighter there. No simplification, all I needed to do is back substitute for u. So the last step to back substitute for u, I'd have the natural log of the absolute value of the natural log of x plus c. Kind of crazy, but that's what it is right there. The natural log of the absolute value of the natural log of x plus C. Really fun problem, really cool problem, tricky problem if you don't know it. If you didn't realize that this was u substitution, probably mess you up on this problem. So look for something like that on the test. Again, me and the majority of other math teachers love putting a problem like that on the test.